Hello everyone, my name is Minakshi. Welcome back to my channel. This is the second lecture of my data science series in which I will cover the topic data preparation. So, what do we understand by data preparation? Data preparation is the crucial initial phase in any data science project. It involves transforming raw, unorganized data into a clean, consistent, and usable format suitable for analysis and modeling. This process is often time consuming but essential for achieving accurate and insightful results. Data preparation is the process of organizing and transforming raw data into a clean, structured, and usable format. Key steps in data preparation. First one is data collection, gathering data from various sources, which may include databases, APIs, web scraping, or manual entry. Second is data cleaning, addressing missing values by imputing, removing, or using alternative strategies. Third is data transformation, normalizing or standardizing data to fit a specific range or scale. Fourth is data integration, combining data from multiple sources into a single cohesive dataset. Fifth is feature engineering, creating new variables from existing data to improve model performance. Sixth is data splitting, dividing the dataset into training, validation, and test subsets for model development and evaluation. Data preparation includes index field, misleading field values, re-express categorical field values, standardized numeric fields using Python, identify outliers. First is index field. Index field is nothing, it is just column or values which helps to track the record uniquely in dataset. Here is the example you can understand by it. Second is misleading field values. Misleading values are incorrect or inconsistent data entries that can confuse analysis. For example, M and male might both appear in a dataset to represent the same values, but this inconsistency can cause issues. Here is the way you can consider it. Third is re-express categorical field value. Re-expressing categorical data involves converting non-numeric categories into numeric values. We convert this data in numeric data because machine learning algorithm cannot apply on non-numeric dataset. Here is the example for converting categorical data to numeric. Fourth is standardized numeric field. Standardization is something like that we convert all other units to a standard unit so that machine can understand perfectly and give more accurate output. Here is the example for a standardized numeric field. Fifth is identify outliers. Outliers are points that differ significantly from the majority of the data. These extreme values can affect the model's accuracy, so we need to identify and handle outliers appropriately. We also can use a graph to identify outliers. Here is the example for identify outliers. Another topic is data preprocessing. Data preprocessing is a crucial step in the data analysis and machine learning pipeline that involves preparing raw data for analysis. The goal of data preprocessing is to inform the data into a clean and usable format, ensuring that it is suitable for modeling and analysis. This step is essential because the quality of the data directly impacts the performance of machine learning models and the validity of analytical results. Importance of data preprocessing improves data quality, enhances model performance, facilitates data integration, reduces complexity. Common steps in data preprocessing is data cleaning, data transformation, data reduction, data splitting, data integration. First is data cleaning. Data cleaning is a critical process in data preprocessing that involves identifying and correcting errors, inconsistencies, and inaccuracies in a dataset. The goal of data cleaning is to improve the quality of the data, making it suitable for analysis and modeling. High quality data is essential for obtaining reliable insights and making informed decisions. Importance of data cleaning. First, improves data quality. Clean data leads to more accurate and reliable analysis, which is crucial for decision making. Second is enhances model performance. Machine learning models trained on clean data are less likely to overfit and can generalize better to unseen data. Third, reduce errors. Cleaning the data helps to minimize errors that can arise from incorrect or inconsistent data entries. Fourth, facilitates better insights. Clean data allows for clearer visualizations and more meaningful interpretations, leading to better insights. Fifth, ensures compliance. In some industries, data cleaning is necessary to comply with regulations regarding data accuracy and integrity. Data transformation. Data transformation is a crucial step in the data preprocessing process that involves converting data from one format or structure into another. The primary goal of data transformation is to prepare the data for analysis or modeling by making it more suitable for the specific requirements of the analytical methods or algorithms being used. This process can enhance the quality of the data, improve model performance, and facilitate better insight. Importance of data transformation. First is improves model performance. Many machine learning algorithms perform better when the data is transformed appropriately, such as scaling numerical features or encoding categorical variables. Second is facilitates data integration. When combining data from different sources, transformation helps standardize formats and structures, making it easier to analyze the integrated dataset. Third is enhances interpretability. Transforming data can make it easier to interpret and visualize, leading to clearer insights and better decision making. Fourth is reduces complexity. By simplifying the data structure or reducing dimensionality, transformation can make the dataset more manageable and easier to work with. Fifth is ensure compliance. In some cases, data transformation is necessary to comply with data privacy regulations, such as anonymizing sensitive information. Data reduction. Data reduction is a crucial step in the data preprocessing phase aimed at reducing the volume of data while preserving its essential characteristics and integrity. The primary goal of data reduction is to improve the efficiency of data, data processing and analysis, making it easier to work with large datasets and to mitigate issues such as overfitting in machine learning models. And here, techniques for data reduction. First, feature selection. This process involves selecting a subset of relevant features from the original dataset, thereby reducing the number of input variables. Second is dimensionality reduction. This involves transforming the data into a lower dimensional space while retaining as much variance as possible. Third, data compression. This involves encoding the data in a more compact format to reduce storage space and improve processing speed. Fourth, data aggregation. This involves summarizing or aggregating data to reduce its size. For example, instead of storing individual transaction records, you might store daily sales totals. Fifth, sampling. This involves selecting a representative subset of the data for analysis rather than using the entire dataset. Data splitting. Data splitting is a critical step in the data preprocessing phase of machine learning and data analysis. It involves dividing a dataset into distinct subsets to ensure that models are trained, validated, and tested effectively. The primary goal of data splitting is to evaluate the performance of a model on unseen data, which helps in assessing its generalization ability. Techniques of data splitting. First, random splitting. The simplest method where data is randomly divided into training, validation, and test sets. This method assumes that the data is representative and that random sampling will yield a good distribution of classes. Second, stratified splitting. This method ensures that the proportion of classes in the training, validation, and test sets is similar to that in the original dataset. This is particularly important for imbalanced datasets where some classes may have significantly fewer instances than others. Third, leave one out, cross-validation, a special case of k-fold cross-validation where k is equal to the number of data points. Each data point is used once as a validation set while the rest serve as a training set. This method can be computationally expensive but is useful for small datasets. Fourth, time series split. For time dependent data, traditional random splitting may not be appropriate. Instead, data is split based on time, ensuring that training data precedes validation and test data. This method respects the temporal order of the data. Data integration. Data integration is the process of combining data from different sources into a unified view, enabling comprehensive analysis and decision making. This is particularly important in environments where data is collected from multiple databases, applications, or systems which may have different formats, structures, and semantics. Techniques of data integration: ELT, extract, load, and transform. In this approach, data is first extracted and loaded into the target system, and then transformations are applied within the target system. This is often used in modern data architectures, especially with cloud based data warehouses that can handle large volumes of data. Second, data federation. This technique creates a virtual database that allows users to access and query data from multiple sources without physically moving or consolidating the data. Data federation provides a unified view while maintaining the data in its original location. Third, data virtualization. Similar to data federation, data virtualization allows users to access and manipulate data from various sources in real time without the need for data replication. It provides a layer of abstraction that enables seamless access to data. Fourth, data consolidation. This involves merging data from different sources into a single repository. Data consolidation may require schema integration where different data structures are aligned to create a unified schema. Fifth, API integration. Many modern applications expose APIs that allow for the integration of data between systems. API integration enables real time data exchange and interaction between different applications. So, we have covered the topic in brief. Stay tuned for further videos. Thank you.